Hello, welcome everybody. Today we are going to present the Data Profiler. It's an open source Python tool by Capital One. Firstly, we are working for Capital One based out of UIUC. Jeremy and Austin are currently working on the Data Profiler, but Chris and I had the opportunity to work on it this past year. So what is data profiling? Data profiling is basically looking at any piece of data and gleaning as much insights as you can, any statistics or informative summaries that might help you make decisions. So our goal is to be able to point to any file, obtain insights for engineering or security or data science. So that means looking at a data file and saying, okay, is this the appropriate schema? Is this, are the columns what they're supposed to be? Or for a data scientist perspective, to look at some data and say, what can we learn about it? What kind of statistics are important? And what kind of decisions can we make based off of that? So one of our major use cases is sensitive data detection. So this is in terms more of security, probably a security point of view, where basically, if you look at some data, can you say, yes, this is a bank account number, yes, this is a social security number, or maybe there's a social security number that's not supposed to be there. And sensitive data just entails anything that could be used to identify you or anything important like bank account information. And then we can also do schema identification. So is this column what it's supposed to be? Is this data entry a string like it's supposed to be, or is it an integer, something like that? And then what's really important for the data scientists is tracking profiles over time. So how is the data changing? How is one data set different from another data set? All of this can be done with the data profiler. So we probably don't need to explain too much to you guys why we wanted to open source, but our biggest reason, our biggest motivation was because if the community likes it, they'll support it and contribute it to it, and we'll make a better product, which makes everybody happy. And we've already gotten a bunch of feedback since we've open sourced, and we're hoping to get more. So with this in mind, we had to think about certain constraints. So if we want to open source, this means we have to have a low activation energy, meaning it's easy for anybody to pick up and use. The installation's easy, using it's easy, making it super convenient or as convenient as possible for the user. And then the second thing is modularity for custom use cases, so that maybe somebody doesn't want to use the whole data profiler, but just a piece of it. And this way they can. And just to have as many use cases as possible without making things overly complex. So with this in mind, we are able to data profile super easily. So that means loading any data source with a single command, calculating a data profiler with a single command, and displaying, updating, or saving a profile with just a simple command. And when we're profiling, we're intending to gather all the statistics in just ON runtime. So it's quick and it's convenient. So if we want to look at how this would look, it's super simple. So at the top here, we have our kind of bread and butter. So you import the data profiler, you point to your data, and you profile it. And then you can print out a human readable report. It's super easy. And then if you want to update and merge profiles, you can use a simple addition operator between profilers to make a new profile. If you want to save and load, you can just do profile.save to the location you want, or profile.load from the location you want. If you want to find the differences, it's as easy as profile1.diff profile2. Super easy and convenient, and gets you a lot of information. So a non-trivial part of the data profiler is the data reader. So being able to take in any data type is not an easy undertaking, and we can ingest CSVs, JSONs, Avros, Parquets, Pandas data frames, text files, this wide array of data types, and we can format them into, typically we put them into a Pandas data frame format, but if you want it as a list of strings or a record format, you can do that. And then you can specify the options about where the header is, what the delimiter is, what the quote character is, things like that. But the data reader will infer it for you. And then this is streamlined to work perfectly with the data profiler. So here's an example. So if we look at the CSV on the left, we can see it's Austin's COVID-19 activity sheet. It looks like it's delimited with @ symbols. And then it looks like the header is actually on the second row. And as you can see on the right, it's perfectly converted to pandas data frame so that we can easily analyze it. And then if we look at nested JSON example, so you might see this a lot in when you're sending packets of data in a network. So there's metadata split with payload. And so a lot of times you want to look at the payload to see if it's what it's supposed to be. And basically we flatten that payload into a data frame so you can easily analyze it. And you can actually add the metadata as well if you'd like, depending on what options you set. So this is kind of like the meat and potatoes. The profiling bit is where we generate the column level statistics. So we generate a huge array of statistics that I'll show you in just a minute, both column level and global statistics. So like what type of file it is, what the encoding is, things like that. And then it's consolidated into one report. So if we look at this structured profiler report, on the left side, we can see the global stats. And so I'm not going to go through them all, but this includes things like how many null rows there are, how many unique rows there are, what the file type is, encoding. There's even a correlation matrix between the columns. And then if you look at the data stats on the right, it's getting kind of small because there's so many. But per column, we can find out if it's categorical, we can find out the data label. So this would be the sensitive data detection, meaning like, is it bank account numbers in here? Is it date times? What's in there? And then there's statistics just like min, max, mode, medium, things like that. We even find like the unique count, the vocab, the quantiles, histograms. So there's a huge amount of statistics and we're always adding more. And we're open to feedback for adding more. And then if we look at the unstructured profiler report, so this would be sending in like just a Word document that's not structured in any way. We can find out the global stats like the file type, encoding, how big it is in terms of memory size. And then we can find the data label entity counts. So this would be the sensitive data found within the Word document. And then we find statistics like the vocab and the words and the word count, things like that. So in an effort to make this more modular, certainly people will not want all the statistics that we offer. So people can turn off statistics or turn on certain features just to slim down computation and reduce runtime where possible. And it's super easy. You just create profiler options, set the ones you want, and send it through the profiler. So one of the most important subcomponents of the data labeler or the data profiler is the labeler. And the labeler is split into 3 subcomponents: the preprocessor, the model, and the postprocessor. So the preprocessor will take in the raw data and format it for your model. Your model can be a machine learning model, it can be a regex model, it can be whatever you want. And it'll take this processed data, it'll perform predictions and confidence scores on it and send it through the postprocessor. And the postprocessor will turn these predictions into readable and meaningful data. So for instance, if you want to just take a data set like we have on the left here and find out what each column would be labeled as, and look, we can clearly see it looks like we have time, phone number, and then someone's SSN. And you just feed that through the labeler and you can get a list of the predictions for each column. And then if we look at unstructured data prediction, it's the same thing. You just set the labeler type to unstructured. and then you send in your text file, and we'll actually give you back the sensitive data labels and where they are. So clearly there's an email from character 43 to character 68, date from 129 to 140, and so on. So if we keep going, we can actually train the labeler fairly easily. And so this means you can transfer learn or reset the weights. You can set how you want to train it. So the number of epochs, if you want to extend or replace the labels, the validation split, and then you can save and load the labeler with one command and use it in the data profiler as you'd like. So this would be helpful if, say you don't care about sensitive data and you just want to know, you want to detect data about cars. So maybe you want to identify when your data is talking about the make and model of a car or something like that. You can do whatever you want. And so you can create your own labeler by switching out any of the default preprocessors or default models or default post-processors as you'd like. And there's options. The default preprocessors and models and post-processors all have options to set as well. So if you want to change certain features about the preprocessor model or post-processor, you can do that, or you could create your own, or you could even create your own class of preprocessor by inheriting our base classes and go from there. And then you can check the pipeline to make sure it all works together. So I'm going to hand it over now to Jeremy, who can show us a demo of how it will work.
Thank you for that introduction, Grant. Let me pull that demo up. Yep. So I'm Jeremy Goodsitt. I've been with Capital One for several years now. Luckily enough, I got to get put on this project. It's definitely a labor of love, but this project wouldn't be here without, the rest of the open source community, because essentially each project that I work on is built off of, the shoulders of everyone before me. And of course, I want to build this project, and our team wants to build this project in such a way that we continue that effort. Grant was, harping on a bit on modularity, and that's something that, in my mind, any sort of open source project, if you can compartmentalize the project, there's always going to be some nugget of good that can be taken from it and used by another team or worked on by another team. And that's why we kind of broke it down quite a bit. And even within our subcomponents, like the labeler or the reader or whatnot, like for instance, the labeler, you can swap out the model. When working within, Capital One's a very large organization. So working on this project, being able to think about how it would apply to open source also similarly applies to how, you get other teams even within your own organization to work on your project. So breaking it up, compartmentalizing, and making things, modular in the sense that another team or another group or someone else that you don't know can refresh or reutilize the ideas that you're using. So that was a huge focus of this. And like I was trying to say from the start of this, was like the labeler, for instance, you can take the model, you can swap it with your own model. We obviously provide a generic model that we created, but that doesn't mean another organization, another group has some specific use case that they want to test and they want to utilize their own model. So it was a huge focus of this. But let me get started with the demo so I can show you some fun stuff. So this will be really basic, nice overview. Importing the data profile, obviously it's Python package. Using the reader, going through some of the functionalities that Grant talked about updating and merging profiles, getting differences. One thing that wasn't mentioned there, that's something that's more recent from the summer, is being able to graph a profile. So you're able to take that data, throw it into our graphing functions, which are simplistic right now, but always looking for help to add whatever is needed. Saving profiles, and of course, the hot topic of data labeling. So I already did this just because I wanted to get that out of the way. Import the library. And then once again, 3 basic components. Just want to be able to load the data. So if someone else, they don't care about profiling, or they don't care about, generating a report, or they don't care about data labeling, if all they want to use is just reading data, we've created a really simple function to do that. It's literally import the data profiler and try and, like we said, as little activation energy as possible. So it's going to load that data. It's going to send it into our profiler, and it's going to output a report. And you guys have already kind of seen what that looks like. So I'm not going to jump through the report, but this is just like data is always loaded through is in like a pandas data frame. And you can apply, what's really cool is we made it so when you load the data, you can apply the functions below. So like if the data is, sourced in as a pandas data frame, ultimately, you can apply the same functions that pandas has below to the data that we have here. So it'll pass those functions on to be reutilized, which is really cool. And then of course, we can dump that report to show what that looks like. So it's going to tell us that same bits of information that Grant talked about. What's in the data, how many null rows there are, how many rows there are unique, what did we source this from? All sorts of interesting tidbits of cool info. And I'm not going to go through all that, but just like jumping in this first column here, you could use simple regex, of course, to determine something's afloat. But our labeler ultimately is going to give a label on a column or on a structured data set. Each column is going to get a label. And then, of course, we do unstructured as well, that I'll get into later. But ultimately, it'll give float. Obviously, tries to label things that are a little bit more complex for regex, like addresses, names. It'll try and grab names versus, cities and states and addresses. But I can jump past that. So, reader, obviously, very cool feature. We're able to take a file. We abstracted it in terms of the sense that each type of data is able to get processed. It checks whether, it thinks that data type is going to be able to match, like if it's CSV, it's going to check the file to see if it, looks like a CSV. If it's JSON, it checks to see if it's JSON, etc. And so it goes down the list. And so I can run this. And so it's going to automatically process these files here, trying to determine what they are. And that allows it to properly, ultimately allows it to properly read it, load it into the data class to then be able to be used by the data profiler. And so you can see here, like CSV is registered as CSV, Parquet is Parquet. And even when we mislabel files, it's not using the extension essentially to determine this information. It's not even trying to think about that. It's trying to be able to read the file and automatically discern what it is. One of the new really cool features is we don't have to just point it to a file that exists on your machine. You can literally just point it to something that exists on the web. So it's going to pull that data in, check which file it thinks it registers with, and load that and display it, and you can throw it into your report, which is a really cool new feature that we've added. So that's like the reader class. Like essentially anyone can come in and use this part of the class. They don't have to use any part of the library. Other teams, either within Capital One or external, if they don't care about profiling a report, that's like one of the most important things, I think, to make something reusable or potentially, have more chance of, being picked up as, an interesting product, is to try and just make things as abstract and modular as possible. And so second big component that was talked about again in the presentation, of course, is data profiling. So I'm not going to go over the general profile. I'm just going to go over like some of the cool, like neat features of it. So like updating a profile or batching or streaming data. Again, we want to think about what sort of use cases anyone might have and to utilize the profile. Big data obviously is a big one, right? Or streaming data is a big one. So you may not be able to take a data profile in, all in one load, or you maybe need to do some sort of map reduce, right? And so that's kind of what we've designed this product around. And so here we're just splitting a data file up, right? We split it into these two sections. And we allow our profiler to profile each one separately. So we'll do that now. And so it first profiles the first one, and then we just tell it to add in the second data set here. And then it'll generate a report, which we can then display and give us all the information that we need specifically about that data set. Obviously, this is a very simplistic data set, so it's not the coolest amount of information, but it's giving us the same information that we saw up above. And so one of the fun aspects about this project is we had to think a lot about in terms of the mathematics of the different statistics of how you do batching or how you do streaming of data statistics to try and combine them together. So that way, you know, whether this data is large, whether this data is really small, any user can come and utilize this product however they may need. And so again, if we have to do some sort of map reduce, the case for parallelization, splitting up both profiles into two components. And then we have this really simple, neat addition where you can just add two profiles together. There are some limits on that, of course. The profiles have to have similar schemas. If it doesn't know how to merge the profiles together, there's no way for that to ultimately work. And again, it's going to do the same thing. It's pretty much like the modularity, the way we've designed this is, you know, updating a profile is almost the same as merging a profile. But again, trying to make this useful for anyone that comes and needs to get statistics on their data set was a fun process to go through and trying to think about all the different ways it could be used. And so this isn't going to print the report since I have that commented out, but really simple, really easy to use. Differences in data. This is a really cool one that has a lot of promise in terms of ways the product could be used. This demo I have here essentially is trying to say, you know, is you a data scientist maybe? If you do a profile on a training data set and you do a profile on a testing data set, and, you know, maybe your testing, you know, data is not performing as well as you think it should be. This is a great way to try and analyze what are the differences between my testing and training data set. What are the statistical differences between these two data sets? So you can take a profile of each one and then simply take a difference between them to get an idea of what's happening within that data set. And so ultimately what I did here is I kind of just grabbed from up above here, we had profile 1 and profile 2 of the same data set that was split in half. And it's simply just saying profile 1, take the difference with profile 2 and tell me what, you know, what do I see different? And it's going to go through all the statistical categories. It'll tell you, you know, we're working on the column name of caret, what things are changed, what things are unchanged. It'll talk about labels, things like that. And I don't need to go through all of this, but ultimately, it's just a really neat, unique feature that's, you know, we're attempting at being able to describe, you know, what's changing in an environment specifically for a data scientist, or what's changing in an environment for, you know, if you have an API, right? And you want to, you know, figure out what's changing in the data set that's coming into your API and, you know, what sort of havoc that might be causing on your system. This would be a great way to see how that's happening. And you can take these profiles, of course, over time. So that was kind of the focus here, graphing a profile. Basically, we wanted to take our reports, and this is a, you know, a newer feature within the library, so it's not as well fleshed out yet. But we're working on that as best as we can. So we've added two different aspects to it. One is, you know, allowing teams to determine where null values are. So it's creating a missing values matrix. And then the next one is taking a histogram. So it's going to do numeric columns, so like interfloat columns only. So like profile is going to determine what columns are interfloat automatically for you, so you don't have to think about that. And then it's just going to generate a histogram. So I'm going to profile this data set here. I'm going to let that load. It's going to get this information. And I'm going to generate these two plots. First one, like I said, will be missing values. So it's going to give us this bar graph, and it's going to show us where all the null values are. And it's not necessary. You could have them, all be the same color and not have a legend, et cetera. But as you can see, there's two different types of null values that were found. One, which is just empty string. Another one was a litany of spaces that showed up maybe one or two times that you could see over here in a comment. So someone, got really excited and smashed the space bar a bunch of times. Either way, really cool, unique feature to be able to understand your data set. And you can start to see, like for instance, really cool to see that source port and destination port. Maybe this is just, entry error, or you see these similarities between columns to, determine, what to try and understand, what's happening in your data set. Why might these things be happening? Are these columns potentially duplicates of each other, or are they just similar in how they're receiving that information? And then just, a natural, bar chart to tell you, what is your distribution of values. You can get that from the statistics within a profile itself, but sometimes it's just easier to understand that visually. And hopefully, ultimately, we can generate this in like a full documented report where all this is combined together that someone can read. But then, all right. So this is another one about, importance to open source, saving and loading profiles. At some point, if people want to transfer profiles between each other, or if they want to share profiles, this is like a profile zoo essentially. Or let's say I'm making the data and I have information that I can't share, but I can share a profile or information about that data set. Saving and loading a profile is one way to be able to give that to, create a, you have a user or someone that's making an API for you. You can't necessarily share the data specifics, but you want them to be able to create validation metrics on your data set. And so you can create this zoo of profiles essentially, or users could have a zoo of information about the data sets that they might be, encountering. So we allow users to essentially save and reload profiles. And so that's all this is doing here. Obviously, we've been loading the CSV data set a lot here, or this diamond data set. And so it's just going to save that profile and load it, and it would generate the same report out that it came in. So that's all we're doing here. Unstructured profiling. So unstructured profiling, as opposed to structured, mostly just text data. Most of this is being applied in terms of the data labeling sense, but we can see it also being utilized by modelers in terms of trying to understand the text or characters that are in their data, whether they need to do some sort of, determine, what sort of encodings they need to build, or potentially if they, filter out different stop words or things like that for building their model. But it can also be utilized, like we said, for, detecting whether sensitive data exists within text. And so you can see here, I have this really basic example that has, I have some random text and then I made up some sort of fake social security number here. And so it tells you information like how much memory that was worth, how all our profiles tell us how long it takes to build the profile and aspects of the profile. But you'll notice, like at a word level, it's saying if I found 5 words that it didn't know about, and one of them was the social security number. Or in this case, it's saying found 11 characters in this text that represented the social security number. The rest of them were some unknown. And by unknown, we just mean generic text. It's not that the labeler doesn't, has issue identifying it. It's just saying like, it didn't seem to match any of the labels that we're generally looking for. So this just must be general text essentially. And so unknown was the name that we came up with for that. And so it describes, different informations about your structured text. And you can do that with a list of data. So here we have like basically a string in a list. This could have been comma delimited, so it was like a true list as opposed to one long string within a list. But we can ingest lists of text. And so as opposed to being one sample in this case, if I had done it instead of just adding as a string, you'd get a bunch of samples, and it would combine all that, similar to like updating a structured profile in batches. This would do something very similar to that. And so it's describing all of the different entities that it found within that. Similar to unstructured, you can merge profiles. So all I did here was add that silly string about the fake social security number, added that profile to the email data set that I just profiled and got information out. So it's going to add, say, we have 2 samples now. We got it from a bunch of different places. So it's not just one file, and then it's simply just merging the information about entities. So now we have an SSN that we didn't have before in the previous one. And then similar to structured again, differences. You can find the differences between two sets of unstructured profiles in terms of entity counts and things like that. So this is like essentially saying one of them had date time, the email had a date time, but my string with the SSN didn't. And so it's trying to label all those unique aspects of it. And then the final major component that we'll end on will be like the data labeling. So right now in the current state in our open source, in the open source repo, we have this model that does all these different labels here. Whether they're sensitive, like driver's license or someone's phone number potentially, or their email address. We also have unsensitive information to help the model be able to digest what information it's getting and make a better prediction. So simple things like integer, float, quantity, ordinal. We have all that. But again, modularity is key. Someone else wants to change out a processor, they can do that. Someone else wants to change out a model, they can do that. They want to change the post processor, they can do that. We have examples to show people how to do that. But here is just a basic concept. So it's just a 3-step pipeline: preprocessor, model, and post-processor. And then I'm going to run this function. That's all it's going to do is give me some extra display helper functions and make it nice and pretty for you guys to see. And so I'm going to load the school data set that we saw in the slides, which was basically it's just a CSV. I believe it's @delimited. And this is ultimately structured labeling right here. So it's going to go to each column and it's going to make a prediction. Obviously for zip, it's saying it wasn't sure if it was an integer or an address. It looked at, the information. It looked very similar that it could be of both of them, which makes sense. Model, of course, is not going to be perfect on everything, but it does, in this case, it did a very good job, in my opinion, of predicting that. Obviously, there are cases where they're not integers. And that's acceptable for it to say, the prediction, landed between both of them, because it's in retrospect, it looks correct. And so it's going to each column, it's making those predictions. And then again, try to make it really easy. Load the data, profile the data, and get the report essentially out from the labeled columns. We can do this again with the unstructured labeling. Here, we're going to load a labeler specifically. We're going to load an unstructured labeler. So if you don't want profiling and all you want is the labeling aspect of the library, that's possible too. You don't have to use the full thing together. You can just use the small components of the library. Here, I'm going to set different parameters of the processor to be able to give us better information, to make it more readable. So I'm just going to run that. Like I said, not 100% perfect. Obviously, this looks more like an integer, and added on a little caret here, called it a float. But it does decently with, here it's trying to grab most of this. Again, it added a caret, but it's calling it email. But here you can see it's a date time. It's grabbing emails. Again, some of this is easy with regex. There are aspects of this that are a lot more complicated and more difficult to be able to grab regex. For instance, like people's names are super complicated. You can create a system, of course, to be able to make those predictions. But having a model being able to do that for you and to do multiple labels simultaneously was really important. But of course, like with our labelers, I don't show this here. You can save a labeler, you can save your models, you can share those models with people, and we would love to have a labeler model zoo that people created on their own data sets and wanted to share with others. Ultimately, this gets to the end of the demo. Hopefully, this gets you a little excited and enticed into the library itself. Naturally, we always want people to give us comments or raise issues or contribute as much as possible to our library, ever expanding, ever growing, and yeah, looking forward to more interaction with all of you.
I can bring it back to the slides if you want to stop sharing.
Great.
Okay, cool. Thanks, Jeremy. So our next steps would be lowering activation energy for contributions, meaning making the code base simpler so that it's easy to just hop in and add things, improving outreach of the data profiler, because now we've made this cool product and now we need to get it out to the world and get more feedback, and then making it easier to share models. So we'd like to create like a sort of model zoo where people can add their own models instead of just the sensitive data detection that we're doing. Does anybody have any questions? I can't see if there's, oh, I can see QA.
I'll go ahead and read one. So can this be used for creating a data directory?
Data dictionary.
Data dictionary, sorry. Yep. I'm not 100% sure what you mean by data dictionary, but we actually use it to basically index what's in like an S3 bucket. And then we are able to track schemas over time. So if the schemas change, for instance, we throw warnings. And we have kind of an automated onboarding process where if you don't know what's in an S3 bucket or you don't know what's in your file system, you can actually start building that out. So I think that's kind of what you're looking for. Yeah.
Yeah, so in terms of, I'm just gonna reference that data dictionary. In terms of unstructured, if you're looking at text, it will collect the different words that it finds, and you can specify separators for words. So if you're trying to get a list of either the characters or specific words within the library, and we would love to have some help adding tokens as well. So if you want to have the profiler search for tokens, that is something that we're looking at. And I also want to go back to what Austin was just saying about one of the use cases is just being able to profile, or like an S3 repository, to be able to point to a location and get the profile and information. You don't have to specify whether it's CSV, you don't have to specify whether it's JSON. It's just going to be able to point, and you can churn through the data sets in that bucket and get the information about what's sitting in there. Next question was, have you used any of these tools on things like image sets, video data, etc.? Would love to add profilers to do that, audio data, etc. That has not been the current focus, but there's a lot of different ways we can take this idea, data in terms of, see it structured text or unstructured, again, same with text, are subsets of all the different profiles you can create, and that could be used by models or data scientists. So image sets, video data, definitely would love to get into that and add that to the repo, but haven't started that just yet. Very good question though.
Looks like Brighton says, is this library available also in R? No, it's just a Python library right now. Perhaps in the future we can migrate it to R if there's enough support for it. Yeah, we'd be willing to make that. Michael Albers says, can the data profiler detect duplicate data? We can detect if the data is unchanged, and we can detect if the rows are unique or not. But that's as far as we get on duplicate data, I believe.
I guess we also look at whether or not like there's a few statistics like unlikability or things like that. We do look within columns as well to see the uniqueness within a column. So column, row, and then the differences would be able to tell you whether everything was unchanged or not.
Cool. Any other questions? Cool. Well, thanks for letting us present. Thanks for giving us feedback too.